Let's give a little help with homework number 24. And to help us do that, we'll kind of answer the questions for a similar data set. And that's from the data Titanic. That movie had that song, near, far, wherever you are, all that stuff. So it's probably made before you were born, actually. So that's kind of scary to me. All right, so we're going to take fifth logistic regression for failure. We're going to do it on Titanic data. So here you can kind of see the Titanic data gives the ID number, what passenger class, whether they survived or not, their name, their sex, their age, something about their ticket number, their fare, what cabin they're in, where they embarked, what boat they got on as they tried to escape, if they found the body. I don't know, some things like kind of gruesome there. But let's go ahead and fit the logistic regression here. So again, what we do is we're going to go to stat regression. We're going to fit binary logistic regression. Where'd I go? Binary logistic regression and fit the model. So we're going to do survived, and the predictors are going to be passenger class and age. I forgot to make a predictor variable for sex, so I put it down here with the categorical data. Maybe we should also put fare. Maybe the more you pay, the more likely that you will survive. So we go ahead and do our regression analysis. And notice that what we get here is female is this one, and then male. And you could kind of see the difference between here, that if male were 1, the coefficient would be negative 2.490. And so we would plug these into our data. So we could actually figure out this would be 4.277 minus 2.49 male minus 1.041 passenger class. So each time you went by a passenger class, you would lose something in your age and then your fare. You could then take a look at what our things are. It does appear that fare just doesn't make much difference, whereas the others do. So I'm going to go ahead, even though that's not in your homework necessarily because you're only doing one, I'm going to get rid of, there I hit regression again. I was so used to that. So binary logistic regression, fit the model. And I'm going to get rid of fare. And we'll fit the model here. Okay, so kind of the first question is fit the logistic regression failure. And so I report the coefficients. I report the coefficients as being 4.63 minus 1.065, negative 0.03198. And actually I could make another one where if I put male in there, I could put negative 2.498 male for that. And then I get the standard error here, 0.366, 0.0958, 0.0064. And then I get the z values that I would write out. So test where the coefficient of temperature is 0. I'm going to go ahead and do it on age. And so I would have negative 0.03198 minus 0 over 0.0064. And while we don't get a t-value per se, we get a negative 5.29, which is, oh man, so far away from having any likelihood of being selected. So we're going to view the probability and to do a normal shaded area. Let's do our x value of negative 5.29, and I think we did both tails, and we get something really 0.006. You probably can't even see that with 8 zeros, so we would reject the null hypothesis and say that it does come in. And since it's negative, since that result was negative, then since that beta is negative, that means it would be decreasing. So the more depths where you go up in passenger class, the less likely that that you would survive. And then I could do a confidence interval for this, and I should probably do this one-sided. And where should I write this? Maybe I'll just write it here. That I would have my estimate, and then I'd have, since it's negative, I'd have minus the multiplier times the standard error. Actually, let me pause and we'll come back to this.